Hi and welcome to this video in the QPSMR Going Deeper series, and in this video we're going to look at arithmetic tables, and this is video 47, and the files will be available to go with this video, of course, as usual. So we're going to start this video by opening up a project where we have some questions already made. So here we are, and I want to talk you first of all through what arithmetic tables are and why you might use them, and then we can look at some of the disciplines or the rules you have to use to actually get the tables that you really want. So I'm going to just start by opening up a couple of tables here, Q12B and Q12C. So I'm going to open up a tables file for these. I'm going to call it tables 1, and I'm just going to specify two simple tables so that we've got something available to work with. So here's gender, picking the rows as 12B and 12C. So there's my two tables, and we're going to run and save that. Now, what I want to do in my arithmetic table here is I want to know the difference in the percentage between the table 1 figures, ease of booking, and the speed of journey, which was rated very important here. So what I want to see is, for the total here, the speed of journey was 18% and the ease of booking was 1%. And I want to see the difference between those two percentages in exactly the same sort of size table in a new table. So I'd get 17% by 18 minus 1, or whatever it rounds to. And same here, 18 minus 1 and 18 minus 1 here. And here I've got 48 minus 9 and so on. So my new table is going to be the difference between those tables, and to achieve that we have to do arithmetic tables, because we're not working with respondents anymore. We're working with calculated figures in tables and taking effectively the figures in table 1 away from the figures in table 2. So let's see how we do that. So first of all, I'm going to insert my arithmetic table. I'm going to call it table 3 for now, and I'm going to say that my table is table 2 minus table 1. Now it's important that you put that hash sign there, because that denotes it's a table. If you leave it like that, it'll assume you want to take 1 away from all the figures in table 2, which would probably not be what you want. So that gives me the definition of table 2 minus table 1. I click down here. Now you can see it's guessed that I get the labels to go across the top from the variable gender, because it's the same shape table as 2 and 1, and it should be said that the tables must be the same size to do this. So these have the same number of rows and the same number of columns. It's the same variable here, but we couldn't do this sort of operation where perhaps this table, Q12B, if that had 12 rows and that had 7 rows, that wouldn't work. And likewise, if we put gender here and region here and there were more regions, that wouldn't work either. The title, though, is not what I want, so I'm going to say something like Q12B stroke C, difference in importance, and I'm going to click OK. So that's set up my table. Now, you might hope that's it finished. It's close, but it's not what we want. But let's run it, and then we can work step by step through what we need to do to get this working. So let's run it. Now you can see my tables have come out for 1 and 2 still. Table 3 is not quite what I wanted. I've lost my percentages. Now the reason I've lost my percentages here is because I've lost my base row. And the reason I've lost my base row is because when I take one table away from the other, 831 minus 831, 500 minus 500, 331 minus 331 is going to give me 0. And so when it tries to percentage these differences on 0, it actually gives the value in infinity, and it prints out a dash just like it would if it was 0. And the 140 looks right to me, so let's just check that. We've got 148 people here, 8 in here, that's 140, 90 in here, 5 in here, and that gives me 85. Now the way I can get that base row to be right is by perhaps not incrementing that and having zeros in here, so it'll take 0 away from 831, 0 away from 500, and so on. So let's just do that. Let's go to table 1, and I'm going to ask for option NITR, which means not increment table row, total row. Now we run again, And I'm a bit nearer now in that table's gone wrong, of course, it's lost its percentage. But the table I'm trying to get is looking a bit more like it now. I'm getting the percentages I would expect. I'm getting negative percentages here, which is correct. But I only wanted percentages in this table. I didn't want the whole numbers. So all we need to do now is put on the format option MPRC to not print the raw counts, save it, run it again, and my table now looks good. Now the only problem I got left now is that this is table 3, and I don't really want to see tables 1 and 2. They're just building blocks for the table I want. So what I'm going to do is I'm going to rename this table. There's a table rename feature here. I can update it, it's the other way of doing it, as 1A. I'm going to rename this table as 1B, which means I've got to rename this table as 1. So I've just made a mistake there, as number 1. But it does mean the arithmetic has now got to become 1B minus 1A. So it would have been better if I'd have called them 1A and B beforehand. Now to stop these two tables coming out, I want another option, NPTB. Now that will suppress them coming out. And this one, NPTB. And I now think that I'm probably going to get the table that I want. If I save it and run it, let's see what I get. And sure enough, now I've just got the percentages I wanted, showing the difference between the answers on question 12C and question 12B. Now this does rely, this particular table, on the base being the same. Otherwise you might get some quite spurious figures here, because if one was based on 831 and the other was based on 400, you would need to do something to get the bases working correctly by multiplying up one of the tables, which would be a little bit more complex. All right, so we've done some work that's been quite successful here. I'm now going to look at another scenario, and we have another project here available, which I'm going to open up. And in this table, we're going to do something slightly different. You can see here in this variable that question 2 asks people how many bicycles they owned, and we have a gender, age and region demographic type question. Now the table I want to produce here is I want to know the average number of bicycles owned for each of the genders within each of the age groups. So my table is going to look like gender down the side, age across the top, just like a respondent table. But the figures in the cells of the table I want to be the average number of bicycles. Now the way that I can do this is by having a table where I get the total number of bicycles owned, another table where I've got the respondents, and then I can divide one by the other to get my mean per cell. Now again, there's some little tricks we need to employ, so we're going to do this in a step-by-step way. So I'm going to now open up a set of tables. I'm going to call these tables 2, and I'm going to insert my first table as a standard table. I'm going to call it 1A this time, and I'm going to pick age across the top and gender down the side, and I'm going to weight this table by the number of bicycles they own at question 2. So this table, when it comes out, will no longer be respondents. It's going to be respondents weighted by the number of bicycles they own. So if they own 3 bicycles, they're going to count 3 times into this table. Now I'm going to make table 1B, renaming that. Oops, I made a mistake there. So let's make it 1B, the same table, but without the weight. Now I do actually need to add a little trick onto here. I need to only let into this table the people who have specified how many bicycles they've got. Otherwise, I'm going to calculate this based on everybody, and if there's one respondent in there or more that doesn't give that answer, my table is going to come out wrong. So I'm going to insert a filter here, which is question 2, and I want the people who are undefined, but the negative of that. So they're not undefined, they've actually given a number of bicycles. I could have said that they've got 0 to greater than 0, or 0 to upwards, 0 to 999 or something like that. But I'm going for not undefined, which is a slightly shorter way of specifying that. And of course I could have just typed that in as Q2 not undefined, and it would have had the same effect as I've done here. So that gives me two tables now. Table 1A is the sum of the bicycles, and 1B is the people who gave how many bicycles they own. And now I can see I've got 47 bicycles amongst 13 respondents. So if I divide this table by this table, I make a new table which gives me the average for each of the cells in this table. So let's specify that with arithmetic. So I'm going to say that my table 1 is table 1A divided by table 1B. And when I click down here, you can see it's guessed what the text is at the top, but I might put my own title in here of average number of bicycles owned for gender within age. Okay, now let's see what I get. It's not going to be quite perfect, but we're getting in the right direction. So let's run this and see what we've got. Well, it's looking quite good. I can now see that when I divide my 20 males that are in total by 7, I'm getting 3 in here. Now, probably I want something more accurate than that. With mean scores, I might want to go to 2 decimal places here, so I need to adjust that. But this percentage here is fairly meaningless. That just means that it's 79% of the figure here. So it's not exactly 3, it's 2 point something probably, and it's not exactly necessarily 4 there, but it's made a percentage of 79% of that, which is not a figure I probably want. So let's tidy up table 1 now and say that I don't want percentages, NRTV. The figures that are coming out are actually the figures in the tables. They're not percentages and they're not mean scores. So it's the DPT format option that I need to set to 2 decimal places. And now I'm starting to get the table that I want. So run it. And now you can see I have got the table that I want. We can check this. So for this cell here, I've got 32 people who are 35 to 54. There's 4 people in the sample, which gives a mean score of 8. The cell below it's 5.50 because we have 11 people here, sorry, 11 bicycles here and 2 people owning those bicycles, and the answer is 5.50. And down here now I've got my table of number of bicycles owned for each gender within each age group. I now can get rid of my first 2 tables, so I can just use those options that I used before. MPTB will hide it, and MPTB here will hide this table. I can save it and run it, and I've just got the table that I want now coming out with the mean scores for each cell in that table. So that completes this video on using arithmetic tables. Users of MRDCL might well know this as table manipulation. Basically, though, what you're doing here is you're doing calculations on incremented tables. You're not working respondents anymore. You're working with figures in a table, more like perhaps calculations that you might make in a spreadsheet, for example, where you're dividing one set of cells by another. Here you're dividing one table by another, taking one table away from another, adding a table together, whatever it is you might be doing. You're building using calculated figures that are in tables. Well, I hope this video was useful to you. You'll find many other videos in the QPSMR series, but thank you for joining me on this video.